So the block of mass m slides along a frictionless track with speed m. It collides with a stationary block of mass big M. To find the expression of the minimum value of baby m that will allow the second block of the circle to make the loop-de-loop without falling off the continuous if the collision is perfectly elastic and perfectly inelastic.
That's funny, baby
So this is like the epitome of energy equations.
Yeah.
You have a baby block, M, and then a bigger block, M. They're on a track, and then it goes around a loop-de-loop.
Yeah.
So the first case is when it's perfectly inelastic.
Yeah.
And what does that mean?
That means that they stick to each other.
Perfect. So this is going at a velocity of baby m velocity, and this is the initial velocity is going to be 0 in both cases. And we want to know how fast this has to be for it to make it around this loop.
So this first one is they're both going to go through the loop.
Mm-hmm.
Right. Okay.
And then the second one, this one's going to be the one that goes through the loop. All the
Right.
energy is going to be.
Transfer to that one.
Yeah.
Okay. So as far as collisions go, you just have P equals mv, right?
Yeah. Your momentum is equal to your mass times your velocity. So in this case, we're going to have our mass or our initial momentum and our final momentum
Right.
of both blocks. So I just write it out like that. mv plus mv equals mv plus mv. This is the little block, big block, little block, big block. This is before and after.
So
You can put the subscripts on it. It's easy to remember that it's just baby block, big block, baby block, big block, and then before the equal signs, the initial, and then after the initial, after the equal sign, it's the final. Let's see.
So it's m1v1 plus mv2 m2v2 equals m1v1 plus m.
Well, I guess it'd be m1 times v1
Uh-huh.
plus m2 times. Well, I guess it's m1 baby m times v1 baby m, m2 big M times m1 big M, m1 big M.
But that's 2.
Yeah.
So this is the initial.
Well, just the mass of the big M and then the mass of the small m, because the masses are going to stay the same throughout. Then this is going to be the same mass of the small one times the velocity 2 of the small one plus the big M, mass of the big M times the velocity 2 of the big M.
Right.
I just don't like writing all that out because it's big and confusing. I just remember
No,
that this.
I just want to make sure I was thinking the same.
Yeah, no, yeah, you're good. So this is the small block, small block, big block.
Right, and the one's the initial and one's the final.
Yeah.
Okay.
And that's a lot easier to write than writing all the subscripts because
Right.
subscripts are terrible. They are very useful, don't get me wrong. Cool. So, what do we have? Or it gives us, what do we have? What does it start out with?
It doesn't, it just,
Like, what are the variables that we get? We don't have numbers, but we have variables.
well, it just says it starts, mass m slides along a frictionless surface.
Okay, so that's
So
this
it's
one right here, right?
Kinetic.
Yeah, so that's this one, this M
Yeah.
right there. And we have this baby M and this M. What's this velocity right here?
0.
Cool. So then that helps. Since it's going to be inelastic, these velocities are going to be the same.
So it's just V final times M plus M, or in parentheses.
V final times, yeah. M plus baby M. Yeah. Dang, this needs to be... I need to wash this board. Can't see it. Are there any... Sorry, it's so...
Oh, that's okay. I can see it.
Okay. Man. All right. So we have your baby M. Make that a baby M instead of a big M. Times the velocity of the baby M. And that is equal to V final times your big M plus your little m.
Right.
Now, do you remember in when you did orbital things, when you did circular motion, do you remember the equation for orbital velocity?
Where it's so you don't fall off the top?
Yeah.
No, but maybe that's what I'm missing in the problem. That's what I don't understand.
So the equation, it's going to be your V is equal to the square root of R times G.
Oh, yes.
Does it tell you the R? Yeah, it does. Okay.
Well, it just says R.
Yeah. So,
Yeah.
but it would give us.
Yeah.
So we're going to use R in our equation.
Okay. Now I get it.
Cool. But this velocity is the velocity right here when the block is right there.
Right.
Well, the blocks, I guess. The big block and the baby block. So this is the velocity right here. So that means that the velocity right here has to be bigger than that, so then it can make it up and then to that point, so then it can go back down.
Okay.
So we have our momentum equation. This V final is going to be the velocity right here.
When it comes back down?
Or at the beginning,
Oh.
before it goes up.
Right. Right.
And we are looking for this velocity? Yeah.
Yeah.
What I'm thinking is we can do the energy equation that you're thinking of, like the 1/2 mv squared and the mgh. Because we will have kinetic energy right here at the beginning, and we will have kinetic energy right here, but we'll also have potential energy right here. And that can help us to find out this actual velocity.
But
right
even
there.
though we don't know the height?
Yeah. Well, we have R.
Oh, so we have 2R.
2R. 2R would be the height.
Okay.
And then the mass would just be the mass of both the blocks. Very cool.